Well, hello again everybody, and welcome to another episode of This and That, or as I like to call it, TAT. And as you can see on the bench, we've actually got a mystery box. In fact, we could call it a black box, but it isn't one of those. So the black box here came from the Dunstable Downs radio rally. Now, anybody who knows anything about either vintage test equipment, or in fact amateur radio equipment in the UK, you will have heard of the Dunstable Downs radio rally. So what it consists of is just a massive car boot sale, which is full of interesting test gears and radio equipment. And I've got to admit, anybody who is anybody was actually there at Dunstable Downs. Now, I didn't actually purchase this unit myself. It was actually bought for me and given to me by an absolutely great bunch of friends that also attended the Dunstable Downs rally. And those people included, I'm sure you're going to have heard of them, included George Christophe, Paul Cody's, Andrew Ausferfer, and not to forget the irrepressible Simon Spears. You can probably see our mystery unit has some catches on here, so we'll just make sure that they're down. And I'm going to open it up and all will become clear. Now, just the other week I was actually asked to modify some software which I'd written and programmed onto an EPROM pretty much 30 years ago. Now, of course, I had no problems actually programming the EPROM, but one thing that I had problems with is I didn't actually have anything to erase it. So what you actually need to erase the stored program on an EPROM memory device, you actually need a source of UV. Now, my friends, having heard about this and knowing that I didn't have a UV eraser, they actually saw this on sale and they saw the label here and they actually went ahead and they actually purchased it for me. Because you can actually see it does say UV eraser for UV EPROMs, £5. Let me just tip up the unit so you can take a look inside. So you can see that it's relatively simple in nature, in that what we've got here is two fluorescent tubes. But these fluorescent tubes are somewhat special. They're not going to give out white light in something like, you know, a ceiling strip lamp. These are actually UV tubes. Now, there is a little bit of a clue here that it says that this is actually a UV exposure unit. It actually says on it here. Now, the actual frequency of the UV light in an exposure unit, it's actually different than the frequency of light that you need to erase an EPROM. So this is an exposure unit. So basically the light output from this unit, it's going to be UVA. So it's going to probably be around 365 nanometers. Whereas if you actually want to erase an EPROM device, you actually need a higher frequency of light. You need something around the 250 nanometer mark. So that's what you would use in a UV eraser. Now, UV erasers can actually be quite dangerous because they actually give out UVC radiation. That can be quite damaging to your eyes and it can burn skin, gives you a bad sunburn, so you have to be quite careful. But this is relatively safe. I think some people would also call this a black light. It's a sort of light that you would find in a disco that would make things like, you know, your clothing fluoresce, especially if you use certain types of laundry detergent. I can certainly remember that white shirts would literally just light up kind of with an electric blue colour. Anyway, maybe we can have a look at that. Now, first things first, let's actually take a look at it, see if we can get it working. Now, this is mains operated equipment, so of course not surprising that it actually comes with a plug socket, and just looking at it, it's an MK plug socket. But if I actually turn it over, you can actually see that it's got a little arrow symbol. Hopefully that'll come out on the camera. Can you see that we've got an arrow symbol on the plug here? Now, this arrow symbol, and to give it its correct name, this is a broad arrow symbol. They call it a broad arrow, and it's actually a really old English symbol. It actually goes back to the heraldry days. It's a really old-fashioned kind of label. Now, it's actually also one of the oldest labels that was ever used by the government to actually mark equipment as theirs. So I don't know if this piece of equipment, this UV exposure unit, it could come from some kind of government research organisation, or it could have actually just been that somebody's actually nicked the plug off another piece of equipment and put it on here. But certainly this actual plug itself is really quite collectible because it is somewhat unusual to find plugs that have this broad arrow symbol on them. So this would be either government property or actually, to get it more correct, it's actually a mark to show that it's War Ministry property. So yeah, quite an old symbol and quite an unusual plug. Actually, there are people, believe it or not, who do like to collect things like 13 amp sockets, and they will actually give a fair amount of money for a plug like this. So this unit has covered its cost just from the plug in itself. And while we are talking about plugs, I just fancy a quick game of plug fuse bingo. So any guesses? I think I'm going to go high today. I'm going to go for a 13 amp fuse. Any guesses? Last chance. 1, 2, 3. Here we go. Oh, fail. 3 amp. So that's okay, isn't it? Well, I'm not going to stand on ceremony today. Let's plug it in. And there we go. It actually lights up. Now, I'm not going to stare at it very long because I'm sure that even though these lamps are relatively safe, I'm not going to stare at UV light. It's probably not a good idea. But yeah, everything's working, so it doesn't look like there's really very much to repair here. Although I have just noticed that the main switch is actually broken, so I'm wondering if we can just replace that with something if we've got one in stock. And just as a quick test, I've got a piece of paper here which I've actually just scribbled on with a highlighter pen, because that is actually sensitive to the UV light given off by this box. Hopefully you can see that some of the inks here are fluorescing quite brightly, so it definitely is giving off some UV radiation. So I've just been and I've had a look through my collection of switches, and I have found what looks like an identical switch, but unfortunately on further inspection it turns out that this switch, it's just a momentary switch. I actually press it in but it doesn't latch, whereas this switch here is actually latching. But what I'm hoping is, but these are the same type of switch, so I'm hoping maybe if I'm lucky I can just pull the front off here and I can actually just push it onto there. Don't know if it'll stay on because there could be something broken, but let's give that a try. Got it. And with a bit of luck we should just be able to actually push this on. Is that going to stay on? Well, that was an easy fix, wasn't it? Well, off camera I've just given this a bit of a clean and it's actually come up quite a lot cleaner now. I think what I might do is, just to try to get it back to a nice black finish, I'm going to take some black shoe polish and go over it, because I think it'll come up nicely then. But one thing I have noticed is that the actual glass itself, I've given it a good clean, but it still looks quite dirty. I don't think it'll show up on camera, but actually there is actually some dirt which is on the other side of the glass here, so we are going to have to just take the glass out and have a look inside. So it looks as though everything comes out from this end, so let's have a go at taking it out. So we did get to have a look inside after all, didn't we? So taking a look inside, you can really see that these units aren't very complicated at all. We've literally just got 2 fluorescent tubes here. Now going to the end, I can actually see that we've also got some of the old-fashioned starter units for tubes here. And we've also got 2 ballasts next to each other. You can see that we've got the mains on and off switch there, just tucked into the corner. Next to that we've also got a little neon indicator. I've got to admit, the wiring on this for an actual bought unit, which this is, I think this is a bought one from RS Components, it is actually somewhat crude. Also not particularly impressed by the quality of the electrical earthing here, in that we've got some wire which they've obviously just wrapped around the bolt here. They haven't even bothered to fit actual crimp ring terminals to it, they just wrap the wires around it. Now there's actually no exposed metalwork on here, so yeah, it really wouldn't make any difference whether that was earthed or not, I don't think. In fact, I suspect they've made it even more unsafe by actually potentially connecting it to the chassis here. I don't know why they've done that, who can tell. While we've got the glass off it, we may as well give these tubes a little bit of a wipe, because they do seem just a little bit dusty and dirty. Yeah, this glass does actually feel quite grubby even on the inside. Just using some of these wet wipes here, which are actually designed for cleaning mirrors and camera lenses and things of that nature. I'm going to finish cleaning this off camera and then I'll bring you back and we'll give it a try. Now, as I mentioned earlier, regardless of what the sales label says, this isn't actually a UV eraser. What this is a UV exposure unit, and it does work at a totally different frequency of UV light than is required for erasing EPROMs, and we'll prove that later. So this particular UV exposure unit is actually designed for making printed circuit boards, and I'm going to call it a photographic technique. So what we use is, I've got my electronics CAD program, and I've actually taken a laser printer and I've printed out the copper tracks where we would want them on our printed circuit board. So all this is a piece of thin acetate sheet, and it's a type that used to be used in overhead projectors. So I actually put this into my laser printer and we actually print the outline of the tracks onto here. And what we're going to do is we're going to do a masking process where we actually expose the printed circuit board here to UV light, but where we've got the black material on the mask, that's going to stop the UV hitting the circuit board. Now, it wouldn't actually be any use just using the mask and exposing the copper PCB material to the UV light. That wouldn't work for us. What you actually have to do is you've got to treat the surface of the circuit board. Now, I remember back in the day you could actually buy circuit board material that came pre-treated with like a specialist lacquer on it which was sensitive to UV. Then a few years later, if you went to somewhere like Maplin's, you could actually buy a spray can and you could actually spray this UV sensitive material on top of the board and do it that way. But since then some other technology has moved on. So one of the ways to do it is actually to use, again, some UV sensitive sheet material to actually sensitize the board itself. Now, I'm not going to make a board today, just don't have time, but I will sort of just show you a little bit of the process. So what I'm going to do is I'm just going to turn some of the lights out because I don't want to risk the daylight in here damaging the UV material. Now, it is okay to expose it to daylight as long as you don't do it for very long. So let me just do this fairly quickly. So I'm going to turn some of my bright filming lights off. Now, I'm not sure how good this material is because I've actually had it in this drawer for a few years and it does actually kind of have a shelf life. In fact, that bit of scrap will probably do. So once we've got that out, I'm going to wrap this up very quickly and I'm going to put this back in a dark drawer because that's where I keep it. Now, before you try to stick this material on the board, it's worth actually just taking something like a Brillo pad, and that doesn't just clean the copper surface. What that will also do for you, it will actually just roughen it up a bit and it makes this film stick to it much easier. Now, the easiest way to actually get this film to stick onto here is actually to wet the surface of the board and try to slide it on. Again, just for speed, I'm not going to do that today. Now, another problem you'll find with this film is it's actually a very soft gel-like material, and to protect it, it's actually a sandwich. So we've got two pieces of protective material, one on either side of the film. It actually can be really tricky to get this off. Sometimes if you're lucky, you can sort of just get your fingers into it and peel it. But I've got to admit, usually not. So there is a little bit of a cheat method which sometimes works. So I've got some Kapton tape here, but actually any tape will do. It just happens to be that I've got some Kapton on hand. You can actually just use a piece of sellotape, that will work fine. So all I've done is I've stuck one piece of Kapton on one side of the material. I'm going to stick another piece on the other, and if we're lucky we can actually peel the protective film off it. In fact, hopefully, can you see it coming off there? So we've actually removed one side of the protective film. So now what we would do is, normally we would wet this board, we would kind of put this on here, and then you actually use a squeegee, because what you want to do is you want to move out all the air bubbles. You tend to get some air bubbles trapped under here, but if you start from one side, you can actually squeegee it out. So the UV sensitive material, at the moment, it's just sat on top of the copper board, but actually what we need to do is we need to get that material actually bonded to the copper, and the way that you do that is heat. Now, there's a couple of ways of doing that. Normally the way that I do it is actually just to put the whole board and this material through a laminator, but for speed, I've actually just been downstairs and I've borrowed the iron from the wife, and what I'm going to do is I'm just going to use the iron. Now, I've got this set to I don't know, I couldn't even tell you. It's just above the temperature that you need to do nylon, and what's going to happen is this UV sensitive material, it should bond, it should stick to the surface of the printed circuit board. Well, certainly that's the plan anyway. I think one of the advantages of using a laminator is that it kind of puts down a very defined pressure across the board. It's probably just a little bit more difficult to do that using an iron. In fact, I've never used an iron before, so not exactly sure how well this is going to work out. So I've allowed the PCB material here just 5 minutes to cool down a little bit. Now there is actually another protective layer on top of this UV sensitive material. Now we need to remove that, and again the way to do it is just to use some Kapton tape. Now this actually is a part of the process which I actually think is the hardest part. Okay, messed up the edge, here we go. There we go, just managed to damage the edge there. You can see this is actually a little bit of a mess. I've got quite a few air bubbles and things trapped under here. You really need to get rid of all them, and I've actually, when I've tried this method in the past, again that's been really hard to try to get all the air bubbles and stuff squeegeed out of here. You've really got to be very careful when you do it. So now we're going to take our UV mask, and I'm just going to put it over the board here. Now this mask that I'm using, this is actually a little bit thin. I can actually see some speckles of light where the ink isn't quite black enough. Quite often you might have to stack 2 or 3 layers on top of the printed circuit board just to make a mask that's actually black enough. It really depends on the quality of your laser printer and probably how good and how new the actual printer cartridge is. This is a pretty old one, so I can see lots of little pin marks in the mask. And finally we come to the part where we get to use the UV exposure unit. So we take our PCB material with its photographic mask and also this UV sensitive material. We're going to put that face down onto the glass so that the light from these UV tubes can actually hit and go through the mask, and it's going to expose the circuit boards in certain areas. Now the actual amount of time that you actually expose the circuit board to the UV light, that's very critical. You can actually overexpose it and you can underexpose it. I can't actually tell you how long it will take. One reason, because I've never used this unit before, but it very much depends to some extent on the strength of the UV tubes and actually how good that UV sensitive material is that we're using. So I'm not sure. So I would probably start off by using a couple of minutes, something like that. So we've got the board on there, we're going to shut the box up, and that's why we've got this foam here. The purpose of the foam is actually to press everything down. Press that down, close the latches, and now what I'm going to do is I'm just going to switch this on. I'm going to wait 2 minutes. Our exposure unit's been switched on now for just over a minute. Let's actually take a look, make sure it is on, so lift it up. Okay, we can see we've got some light there. Let's turn that unit off. Now one of the things that you can do using this process is you can actually inspect it part way through, and in theory we should be able to see, in fact it's done it already. Hopefully you can see there that the actual image that has been actually photographically reproduced on the circuit board here, and that's probably not bad at all, that actually. That has actually worked. Let me bring you in so you can see it a little bit better. So if I just peel off our mask here, we should be able to see the parts of this UV sensitive material. Some parts have actually been exposed to UV lights, whereas other parts have actually been masked off and haven't seen the UV light. So the parts of the board which are in dark purple, these are the parts that have been exposed to the UV. They've been in contact with the light, whereas you can see there's some paler material here, which is, well, it's actually just basically the copper colour, isn't it? Well, where you can see the copper colour of the material, that area's been masked off and hasn't seen UV. So one of the good things about this process is you can actually stop it part way through and you can actually see if we've correctly exposed the board. I actually think that we've got pretty good exposure on there because I can see that we've got this good definition between the dark purple and this copper colour. So we have actually exposed the material to the UV for long enough. But if we haven't, all we actually have to do is we put this back on top here. Because we taped it on, it will actually line up where it was before. And then you just put it under the UV box for another minute, take it off and have another go. Now the process of making the printed circuit board isn't yet complete. The next step is actually to take the circuit board here and we actually have to drop it in a solution of sodium carbonate. Wherever you see the material is blue, that will actually stay on the board like paint, but wherever the actual material has gone white, there is actually still this UV material on there, but the solution of sodium carbonate, it will actually wash away all the actual white areas of the board. That will wash away, leaving just the actual blue stuff or the purple stuff. So then when we've washed away the material where we want the board to etch, we take the circuit board and we actually drop it into a ferric chloride solution. And again, where you can't see the purple, that's the area that's going to get etched away. Now I've noticed that unfortunately when I actually made the solder mask, I made a bit of a mistake because I actually must have had all the layers selected, because I can actually see the component outlines and I can also see the component ident layer. So I've actually printed all the layers onto the mask. That's wrong because you don't want them printed on the copper side. That's just my mistake because I was rushing. I'm not going to try and etch the circuit board today because I simply don't have the time, but hopefully you've seen the principle of it. And what I'll do is I'll actually put a link into Big Clive's video where he will take you through this process. You can see it all in full. Now of course there is actually very many ways in which you can make printed circuit boards. I dare say the very easiest way is actually just to get them made in China. You can get them made so cheaply now, it isn't really worth doing it yourself. You can have them boards made for just a few pounds. The reason that I like to make my own boards is because I actually enjoy the creative process. I like making it by hand. I enjoy the craft of it. Now there's actually many ways you can make printed circuit boards at home. This is just one method. Now the advantage of this method is once you've actually made this photographic mask here, you can actually use it to produce many boards. The other method that I tend to use for just one-off boards is a method called toner transfer method, where we actually apply the toner from a laser printer. We actually put the toner from a sheet of paper, we use an iron and we actually transfer the toner onto the circuit board, and we actually use the toner from the laser printer to stop the etching, the ferric chloride, from getting at the printed circuit board material. That's good if you're just making a one-off board, but if you want to make more than one board, the actual cost of putting all this toner down gets expensive, whereas, you know, in theory you can use the actual mask here itself. You can use it as many times as you want. It doesn't really wear out. So that's the advantage of using the UV light box over the toner transfer method. But again, I'll put a link in the show notes so that if you want to see me making circuit boards using the toner transfer method, I'll show you how to do that. So having tested the light box and given it a little bit of a clean, I'm just wondering, can we improve the cosmetic appearance just a little bit better? Because I can see that the surface, I'm almost going to call this like a leatherette material. It does seem just slightly damaged and a little bit scratched. So I'm wondering if we can improve that. So what I've actually gone ahead and bought is, I've just bought some of that black shoe polish which people use as, well, it's a scuff repair, isn't it? Don't know if this will work, so what we'll do is we'll just try a little bit on the underneath, and if it looks a mess, then yeah, we won't bother using it. I seem to remember that back in the day the pigment for this shoe polish was quite a lot thicker and it seemed to cover better. Maybe some varieties or some brands work better than others. I think that has improved it cosmetically. Having watched this video, some of you might decide to play along at home and actually have a go at making your own printed circuit boards using this UV method. Now of course, if you're just trying it for a one-off, you might not want to go to the expense of actually purchasing one of these UV exposure units. You can actually still buy these from a variety of places. I see that they do list some at places like Farnell, and you can also buy them on eBay. I think the cheapest unit that I've seen is about £150, and then they tend to go up from that, so you can spend as much as you want, but that's quite expensive just to have a go. Now, of course, I only actually got this unit last week, so what I used to do before I had this is I used to use this UV light source. Now, I bought this from Amazon, and I believe it's something that ladies would use for curing nail polish or nail glue. So they have something done to their nails, and then basically they put them underneath this unit, and as maybe you can see, it's got some UV tubes in it. Let's plug it in. So hopefully you can see that we've got some UV lights here. So I believe that what women do is when they have their nails done, they actually put the nails under this UV light, and it actually cures the glue or the resins on their nails. But if you want to have a go at actually getting one of these, I think you can buy one of these for probably £15 or less on Amazon, so they really are quite cheap. And all you actually need is, again, you need some way of printing out the actual mask, and of course you've still got to use this UV sensitive film. You've got to apply that in the same way, but all you actually need to do is you take your mask, put it on top, and then I've got some old piece of glass here that came from a picture frame, so you just put that down on top of there just to press everything down, and then just take the UV light box and actually put it on top like this. And I actually found that this would expose a board in about a minute, so it does it relatively quickly. I have to say that I find the process of actually applying this UV sensitive film to the top of the PCB, it's the hardest part of the whole process, and it's quite time consuming. It's easy to make a mistake and get it wrong. Now, back in the day, you could actually buy some spray paint that was UV sensitive, so you could just take normal PCB boards, you would spray them, let them dry, and then you could put the mask over it. That used to work. I don't think you can buy that anymore. You can actually buy PCB material that's actually got the sensitive film already on it. Now, you do pay a little bit more for that. Well, you actually pay quite a little bit more for it, but I think you would probably get better and, well, more stress-free results, because, as I say, this method is a bit of a faff. And if you do decide to have a go at making your own PCBs, you're going to need various materials, PC board, chemicals, things like that. I suggest that you use a company in the UK called Mega. They can actually supply from very small quantities of equipment right up to professional setups, and they have all the chemicals and the exposure units and the drills, everything you could possibly need for making your own PCBs. And I think they're probably still the best supplier in the UK, and although you can buy most of the equipment still from places like Farnell, they are quite a lot cheaper than Farnell. So again, have a look in my show notes and I will put you a link there to the company called Mega. Now, going back to the start of this video, I actually said that my friends bought this UV exposure unit because I had some EPROMs to erase and they thought that it would be suitable. Well, unfortunately, it isn't the case, and we'll go ahead and prove that shortly. But while we're talking about various types of UV systems, I just wondered if any of you have seen this relatively new UV epoxy resin. So we're all familiar with two-part epoxies, such as this araldite, where you actually have, well, two materials in a syringe here. You squirt them out, you mix them together, and over a period of minutes the stuff actually sets hard. This is a similar epoxy product, except that you don't actually have two parts to it. The curing agent is UV light, so actually all you've got to do is to expose it to a strong source of UV, and this stuff will cure pretty much instantly. I think they use a very similar system now for repairing teeth and things like that. They certainly do use some UV curing resins. Now, there's different ways you can actually cure the resins. So you can actually use light boxes like this one or like this one, but you can even actually just buy a little handheld torch. So let me just show you that, because some of you may not have seen these UV resins. I actually certainly like them because it's pretty much instant. You've got no waiting time. And the other thing is it tends not to go gungy or get too sticky. So here I'm just going to put a splodge of there on there like that. And hopefully you can actually see that's running. I'm just going to mix it up a little bit. In fact, maybe can we just balance something in there? So I'm going to take this UV torch now. I'm just going to shine it onto the resin. And this torch really isn't very powerful. And there we go, the actual resin has, well, it's not set hard yet, but certainly it has actually started to cure already. It is almost pretty much instant. As soon as it gets the UV light on it, this stuff just seems to set. Amazing. And there we go. That time we actually used a little torch light. You don't have to use a torch. We could actually probably even use a light from our light box here, so we'll try that as well. So just squirt some of that out. Okay, I think that's probably been about 10 seconds, hasn't it? And there you go, our resin is set. Just one word of warning, when the epoxy resin is in the uncured, in its runny state, just out the bottle, it is potentially quite toxic, so if you get any on your hands, you need to wash it off immediately. It is quite nasty stuff, but once it's actually set hard like this, it is pretty much benign like any other plastic or epoxy. Getting back to where I started, you can see on the bench an EPROM. In this case, it's an M27256F1, which is an NMOS 512 kilobit device, and it's manufactured by ST Electronics back in those heady days of 1993. The word EPROM is actually an abbreviation, and it stands for erasable, programmable, read-only memory. The operating concept of the EPROM was discovered at Bell Labs in 1967 and was actually one of those happy accidents that came about when investigating something totally different, which was transistor failures. However, it didn't find commercial use until a few years later, when in 1971 Intel announced the first commercially available EPROM device, which was the Intel 1702. And this was a 2048-bit memory device. So we're not even in kilobits here, we're literally just talking numbers of bits, 2048. However, this was heralded as a huge step forward, with the advantage of the EPROM being that data is still retained even when the power supply is switched off, whereas previous memory devices had either been very fragile, very large, or excessively power hungry. Now, the underlying technology that allows the operation of the EPROM is based on a large number of field effect transistors, each with a special insulated gate arrangement that forms a capacitor. These transistors are grouped together to form memory cells, with many thousands being required to store just a relatively small amount of information. At the time of programming, the EPROM stores information by selectively charging up the transistor gate capacitances. Now, some of those gate capacitors will be charged up and some of them will be left in a discharge state. In this way, binary information can be encoded in the many thousands of transistors. Once the information has been written to the EPROM, it will be retained almost indefinitely. But in real terms, information is retained for as long as it takes the stored charge of the gate capacitances to dissipate. Luckily for us, the charge will remain for a long period of time. Device manufacturers typically guarantee that information will be retained for a minimum of 20 years, with a maximum retention being about 30 years. However, with some devices now reaching 50 years of age, it's not unsurprising that EPROM failures aren't uncommon, and this is only going to increase over time. So if you have any old equipment that contains EPROM devices, it's probably worth reading the data on them and backing it up somewhere, just in case the need arises to refresh or replace the EPROM. Now, once data has been written to the EPROM, it's fixed, and it cannot be changed or modified without first erasing all the stored information on the EPROM. Now, the way an EPROM is erased is by removing the electrical charges that may be stored on the gate capacitances of those transistors. The way that this is done is by exposing the transistor gate capacitance to ionising radiation in the form of UV light. Now, I don't understand the underlying physics, but the wavelength of the UV light is very important to the erasing process. The photons of light have to have sufficient energy to be able to dissipate the stored charge by knocking off electrons. Light wavelengths around 250 nanometers, also known as UVC, do have sufficient energy to do this, whereas the light that is output from our exposure units is UVA, and this has a wavelength around 350 nanometers, and it doesn't have sufficient energy to storm in there and knock off those loose electrons and dissipate the stored charge. And that's the reason why we can't use an exposure unit like this with its 350 nanometer light source. We can't actually use it to erase an EPROM, but let's go ahead and prove that. So this is the EPROM that we saw earlier, and I've got to admit, got no idea what it came from. It's probably a unit that I programmed myself more than 20 years ago, so unfortunately I've got no idea what's on it, but we can actually find out. So the way we can do that is, I've actually got this little EPROM reader and programmer unit here. This one is made by Mini-Pro, and I really do recommend these. These are great little units for the cost, really useful. So I'm just going to put that in. And what we can do is we can actually read off the stored data. In fact, we can actually see if there's any information left on it, because it could have dissipated over the last 20 years. And all we have to do using the Mini-Pro is actually select the EPROM devices, a huge list of different devices, and then we just have to click the read button here, and it will read off all the information, and we can actually see it on the screen or write it to a file. So I'm just going to press the read button, and I'm going to press read again, press read. And there we go, as quick as that. So it has actually read the contents of this EPROM. And you can see now that this table has actually been populated with data that's actually been read from our EPROM device. Now, we've got no idea what the data actually is, but certainly I can tell just by looking at it that stuff has been written to the EPROM, and it does actually still retain the information. So let's go ahead and try and erase our EPROM now. So I'm just going to take it out of the programmer. And do you want to have a closer look? So hopefully you can see that, but the most recognisable feature of an EPROM is that we've got this little window here. Now the window is actually made from a specialist glass, and it's called quartz glass. You can't use any old glass. And of course the purpose of that window is to let our UV light in, so it can get at all these little capacitors in here and actually discharge them. So let's go ahead and put this onto the light unit. So I'm going to position this directly over the top of one of the tubes. I'm going to close that up. In fact, just to prove it's on, we'll switch it on. I'm going to get blinded. There we go. Close up the unit. So in theory, all that UV light now is going to be flooding through the window on our EPROM, and it's going to be discharging those gate capacitances. However, the light source has got the wrong frequency at 350 nanometers. It actually needs to be a higher frequency of light with a shorter wavelength. So I don't think that this is actually going to erase. But what we're going to do is we're going to give it a good chance, because I'm going to leave this going for 15 minutes. Well, 15 minutes and 1 cup of Bovril and sherry later, it's about time to open up our exposure box. So let's just open it up. Let's check our lights are still on. Yes, they are. Okay, let's switch the unit off, open it up, and let's put it back onto the reader and see if it still retains any data. I think it will. So let's go ahead and press the read button. After 15 minutes of erasing all the information within this EPROM, it does remain intact. So our UV exposure unit, unfortunately, hasn't done anything to erase this EPROM. So as it turns out, when it comes to erasing EPROMs, we do actually need a UVC light source in the 250 nanometer range. Now, back in the day, there was very many devices commercially available designed for erasing EPROMs, and over the last 30 years I must have owned several of them. However, given the fact that EPROM technology has been surpassed by several other technologies, including E2 memory, which can be electrically erased, the actual call for these commercially available EPROM erasers is low, and there really isn't very many of them on the market these days. However, luckily for us, and due to the global pandemic, there are now many hundreds of different types of UVC lamps available to us, often sold under the name sanitising or germicidal lamps. And many of these will have a wavelength of 250 nanometers and as such are quite suitable for erasing EPROM devices. Now before going any further, I have to give a safety warning. UVC lamps can be seriously dangerous. Whereas UVA and UVB lamps might help with the suntan, I'm afraid that UVC lamps skip over that and just go on to serious sunburn. When UVC lamps are used in a germicidal application, they actually work by destroying and disrupting DNA. It renders DNA inactive by smashing it apart, causing mutations, and in some cases can cause skin cancers. And if you are unlucky enough to stare into a UVC lamp, even for a short period of time, eye damage and in some cases permanent eye damage can occur. So these things aren't toys and aren't to be played with. Well, I think it's probably been around 20 years since I've needed to erase and reprogram an EPROM device. And because this isn't a job that I do frequently, I really didn't want to spend a lot of money buying a dedicated EPROM programmer. So what I did instead was do a search on Amazon to find absolutely the cheapest UVC sanitizing lamp that was available. And this is what I came up with for, well, I think this cost about £4.50. And what this is, it's a little battery operated lamp. And of all things, it's actually designed to go on a toilet bowl. So when you put the toilet seat down, it actually turns the lamp on for a few minutes. And in theory, that kills all the germs and bacteria. Really not sure because I'm guessing this is a very low powered lamp, but it is actually a source of UVC and I am fairly sure it will actually erase an EPROM device. So to operate this you have to switch it on, and it's got kind of an accidental dead man switch, so you've got to press the button down and hold it on and you wait until it bleeps. And when it does bleep, you get a green light here to say that the unit is turned on. But it's actually got another safety interlock, so you can probably see the tubes actually haven't lit up as yet. What you've got to do is you've got to turn it upside down. Hopefully, there we go. Can you see that? The little tubes have lit up. If I actually tilt it the other way, they turn off again. Can you see that? They're just turning on and off. So this is a little safety interlock, which is designed to stop you being exposed to the actual UVC light. Now, I don't think this would probably do you a lot of harm, especially if you weren't actually to stare into it, because I assume it's very low powered, but I'm fairly sure it should work to erase an EPROM. Let's find out. Okay, so I've fired up the Mini Pro again, so we can actually just do a read on this and make sure that it has got some data on it, so I'm just going to press the read button. And the data is still there, untouched as before. Now this actual Mini Pro also has another little tool function here, which we can actually just check to see if a device has erased. So we've actually got this blank check button. So what we can do is we can keep pressing this button and it will tell us when the actual EPROM has been erased. So it's saying not empty. It's detecting code there. So what we'll do now is got to do a few things at once. So I'm going to switch this on. There we go, it's bleeping, so I'm assuming it's going to turn on now. Yep, that's on. I'm going to start the timer. And now all I'm going to do is I'm going to put this little eraser device on top of our EPROM and we'll just keep pressing the blank check and, well, let's see how long it takes. Okay, 30 seconds in. 30 seconds in, we've still got memory. 60 seconds in, still got contents in the memory. Coming up to 1 minute 30 now. Oh, 1 minute 30 seconds and our device is now registering as blank. So 1 minute 30. Normally when I used to erase EPROMs in the past, it used to take quite a long time to do it. It used to take, well, I used to put them on for about 10 or 15 minutes. This appears to have done it in 1 minute 30 seconds. Now just to check that that is correct, because it is telling me it's blank, what we'll do is just cancel that and we'll actually do a read from the memory device here. So press the read button and you can now see that all the memory locations are coming up with the letters FF. So this EPROM is in fact blank. Now I have to admit, I've got no idea, would we get a longer life and a better performance out of the EPROM if this was left to erase for a longer time? I'm not sure. If you know, leave it in the comments. But I think for today, as always, thanks very much for watching. But until next time, bye bye for now.